So if you've ever wondered how a major car maker develops a 4x4, well, this is the video series for you, because I've been talking to two Toyota engineers who've been closely involved in development of the new LandCruiser 300 series. Now, I've split the results of that comprehensive video up into 4. This is the first part, focusing on the development process. Then we talk about off-road technology, a deep dive there. Drivetrain and dynamics will be the third video, and the fourth will be accessories and specifications, all of which are going to be indexed at my website l2sfbc.com/LC300. Now, this is a technical interview and there is a lot of technical terms, and I've explained all of these in my LandCruiser prototype drive, things like AVS and EDKSS and brake traction control and yaw, etc. All of those are in that video. There's also a reader Q&A which you may find of interest, and if you're into towing, then you definitely want to take a look at this, because that's a detailed analysis of towing weights 200 series versus 300. Doesn't matter how well the vehicle can drive, if it can't tow the numbers, then the numbers just aren't there and you're not going to be going anywhere. Now, in this video there are chapter links, so you can jump around to the parts of interest. And with that done, let's meet the engineers. So Ray, thanks for joining us. Could you just give us a bit of a background as to what you do with Toyota and how you came to be involved with the LC300 development?
All right, yeah, thanks Robert. Thanks for having us on. My name's Ray and I lead the vehicle evaluation team that looks after the durability and environment evaluations of our off-road vehicles within Toyota. So TMCA has responsibility for the off-road and commercial vehicle evaluation within Toyota. They develop the cars in Japan and design them there. We test them in Australia. So yeah, our team looks after the things such as customer interviews, developing targets, and then evaluating the vehicles in the real world and feeding those issues that are found back to the design centre.
Okay. And how long were you involved with the LC300 program?
This one we started back in 2014. So it's taken 7 years from right at the beginning of the kickoff of the program. So yeah, a long time.
Okay, good. All right, and welcome, Kirsty. Thank you for joining us. Could you just give us some background as to your involvement with the LC300 and how you came to be here?
Yeah, so my name's Kirsty. I work in the Advanced Systems Development Group in Vehicle Evaluation at Toyota Australia. My group does a lot of kind of research and development in the off-road space in Australia. And we also get a lot of work with evaluation and refinement and tuning of the, and contributing to the refinement and tuning of the MTS systems in LandCruiser 300. I personally have been on the program for 3 years and I found it to be an absolute privilege working on this car.
Okay, guys, can you just give us a bit of an overview as to how a vehicle is developed? Because at some point, someone in Toyota must have sat down and said, okay, the 200 series is not going to last forever. We need to do another vehicle. What should it be? How are we going to do it? What sort of happens there?
Yeah, it's a good question, Robert. In terms of vehicle development, I think it's pretty standard across the range. It starts by setting targets. So you have to have a target which is set by the chief engineer group so that everybody kind of works in the one direction. For a vehicle like the LandCruiser 300, that target setting actually began way back in 2014. And it goes through a deep process of firstly studying the customer and the current situation. So Toyota has a term called Genji Genbutsu. That means go to the source. And literally what we did was we met customers with chief engineer and his group coming over from Japan. We met customers that were driving in the outback, customers that were based in the city, customers from LandCruiser clubs, customers that own farms, all those range of customers. We pull together the interviews and the way that people are using the cars. We then look at what's going with things like regulations, where the market is heading, and then from all of that, a target direction is set. Once that target direction is set, and there's a lot of work to make sure that's, you've got to do a lot of future postulation for that. Once that direction is set, then the design team start to work on how they can make that the vehicle that will meet those targets. What technology that they need to put in? What are the challenges coming up? Once those parts have been designed, then prototypes are made, and that's where those prototypes are tested for Toyota. They've got very strict testing in Japan, but to make sure that we cover the the environment that the customer drives in, those prototypes then also come out to Australia, which is where our group gets involved. So we might be testing some of the new technologies, we might be tuning some of the systems, and as the prototype phase goes on, more and more parts get added on, and you end up evaluating the whole vehicle. So those are going through testing them in all the different conditions we can to make sure the performance and the durability meets the targets. And that goes right up to the very final stage of production to make sure that the production cars are meeting those same targets that go on that have been met by the prototype vehicle. So yeah, in this case, it's taken 7 years. It's a long process to get it right. The commercial vehicles and off-road vehicles do have a lot of work to go into them to achieve that, to make sure that they are then the right vehicle for the LandCruiser into the future as well.
Okay. How do the targets, I guess, from the customers in Australia differ from customers in Russia and the Middle East, which are the other major markets?
Yeah, as you said, they're the three major markets for LandCruiser. What's been found is that the Australian customer, we are very remote areas, which are also found in some of the other parts of the world, but we tend to have more customers using the vehicle in the way that it was intended as a LandCruiser, people that rely on this vehicle to live their life in very remote areas. So for example, we have customers such as the Outback station owners. They might live 400 or 500 kilometers away from a town. They rely on this car so that they can safely weekly go do their shopping run. For you and I, a shopping run is 5Ks to the shops. For some of these guys, the shopping run is 1,000 kilometers, maybe 800 kilometers on dirt. So we tend to have those longer, more remote driving situations that are part of everyday life. We also accessorize our cars very heavily. So bull bars, tow bars, a lot of towing goes on. So what has been found through all that research is that if a car is made suitable for the Australian customer, it really does work very well for the global customer. The only thing that we can't really test here in Australia is the extreme cold they might get in a place like Russia. So that is evaluated elsewhere. The Middle East has very high sand component and high temperatures, but we do have that in Australia.
So we had the 200 series. Was the 300 a clean sheet design, or was it a case of look at the 200 and, okay, that seems to be doing the job, how can we make it better?
Yeah, this is a clean sheet design. Everything on it is new. To meet the targets that were set for performance and efficiency, it was new. And not only is the hardware new, but all the electronics, that whole platform of the electronic system is also new. So anything to do with the control systems and the logic behind those. So yeah, it is a clean sheet. There are some things that will look familiar when you look at it because it's building off previous knowledge of the 200 series, but yeah, this is an all new vehicle.
What sort of specific feedback came up in, I guess, talking to the owners, which had effect, saying, look, we really like this, really like the other? I think when we did the prototype test, we were talking about how getting into the back of the vehicle, you open up the door and then the wheel arch comes away with that so you don't get dust on yourself. Any other anecdotes like that?
We did get a lot of feedback on, especially items such as accessorization, making sure that the vehicle could be accessorized. That was really one of the really big feedback items we had. We can't make a car that has everything on it. That's why we have especially the genuine accessories, making sure that they can be fitted onto the vehicle.
Okay.
Yeah, and from an off-road perspective, we found a lot of our LandCruiser owners are telling us that actually a lot of off-road driving happens in H4. So they're driving in conditions like sand, like mud, and dirt. Particularly, a lot of our roads here are dirt, and the feedback they're giving us is that the on-road kind of biased control systems were far too intrusive in these environments. So now in LandCruiser 300 we have dedicated H4 modes for sand, for mud, and especially for dirt. And the dirt mode has been developed particularly with the Australian user in mind.
You asked before what was some of the feedback from the customer.
Yeah.
The devices, like LC300 is an amazing machine that could get everywhere, but the devices were quite abrupt and noisy and a little bit difficult to use. So this was one of the points that customer feedback led into very direct development. Was you'll notice now you can leave the crawl and DAC system on, you can drive through it, and so you can control. Then when you take your foot off the throttle, it's very smoothly takes the control of the car over from you. The control system layout is much, much easier. So they were all direct results of the feedback we received from customers that there's these fantastic technologies on the car, but we need to make them very usable. And one of the things that we have in a natural country like Australia, I'm sure you've been into the high country many times, is that the scenario is always changing, and you're in low range for a very long time. It's not like you're going to an adventure park where you've got a steep climb here and a big descent there. You've got all kinds of, you've got to drive on the flat between these. Then you come up to a climb, and then you've got to kind of come over the top of a crest. You want the systems to be there backing you up so that, okay, I let my foot off and now it lets the car crawl really smoothly. You don't want to have to keep turning them on and off all the time. So that was one of the key development areas, was to make these technologies able to be left on the whole time. So they're there to back you up, and you don't need to keep switching them on and off.
To the topic of graceful degradation, which so this is a concept which I used to say, look, if you're out in the outback somewhere on a four-wheel drive track and there is a failure of the car, for example, a wheel speed sensor breaks or ripped off, whatever else there, or something happens, then the car should not just go into limp mode. It should continue to operate. And I actually think that modern vehicles disobey Isaac Asimov's 3 laws of robotics, because they put the priority of the vehicle, the health of the vehicle, above the health of the operator. Right. So I'm keen to know, let's say that you're in your 300 and something happens, I don't know, hose blows or wheel speed sensor goes out, and this car starts to degrade. What sort of design has been done to ensure that the vehicle can still keep going on and doesn't just go into a limp mode full of warning lights and goes, oh, no, I'm just not going any further?
Yeah, it's a really good question, Robert, and it's a subject that I'm also very passionate, and I know we discussed a little bit previously about. Yeah, there's a lot of thought that goes into this for a vehicle like LandCruiser, and I'll take you to a saying that right from the beginning of the development of this, the chief engineer, who was chief engineer of 200, he had a term called LandCruiser. It's kind of shortening the Japanese LandCruiser, and it's that the vehicle can't just get you there, it has to get you back. And so there was a lot of development and priority thinking put into systems that are, let's say, I mean, we have to prioritize safety over everything else. So if a critical system goes that you can't drive the car, it's a different story. But when you have these systems that are kind of the add-on systems that aren't absolutely necessary for the car to move, you might get a warning light, but they shouldn't disable the basic function of the car. So yeah, a vehicle like the LandCruiser 300, there's a lot of thinking into those systems. And if you do have a critical system, then that system needs to be very well protected and really well validated to make sure that it's not going to cause a failure. So it is a, right from the very beginning, the chief engineer, this term LandCruiser, he instilled that through the whole design group and everybody that was involved, that this needs to be a core kind of feature of the LandCruiser, is that these little things don't stop you unnecessarily.
Have you got any examples of that? I mean, I came up with wheel speed sensors because I've been in situations off-road where a wheel speed sensor has sent a vehicle into limp mode, and I've gone, well, okay, so if I don't have ABS and traction control, surely I can still go, right? But apparently not.
No, look, wheel speed sensor is a very good example. You'll get a warning on the dash because it does mean that maybe some systems can't function. You shouldn't be driving without that, but it won't stop you from driving, and it'll allow you to continue to go home so you can take it to a repair. We do prioritize a lot of work. If you look under a car like the 300, you'll see that there's a lot of work done, which is probably even hard to really see, but how much work is done to hide those things from being able to be hit by rocks and sticks, so that ideally we don't want them having a problem at all, but the control systems are designed so that you can get home.
Yeah, and the lockable center diff, to my mind, helps that as well, because you then don't have another computer trying to figure this out. You can just go, because otherwise you're in there potentially in one-wheel drive. Do you have any more stories about the development, like that one you told me about the engineer in Tulangi and switching off his phone and going, oh my God, there's no phone signal. What planet have I come onto? What are you guys doing? Because that was really interesting, just to highlight the importance of how development is done. Anything else like that comes to mind?
That was where we did take the engineers out into some remote areas, and even not that far out of Melbourne, we've got the Tulangi forest. We drove into the forest there, no phone signal to really drive home the remoteness we have in Australia. I think for our engineers that are in Japan who are extremely dedicated and really passionate about LandCruiser, if you've been to Japan, you don't have that remoteness. So that was a really eye-opening experience for some of these guys. It's the first time they've been in a place without phone signal. Maybe one of the funny little stories I can tell you was there was a lot of focus on when a prototype's coming to Australia, and we had prototypes hidden in plain sight for many years. There was a spy photo a couple of years ago where actually it was a TMCA vehicle, and someone had photographed a LandCruiser 200 with some sensors on it and a Japanese team driving. It was actually the vehicle that was photographed was a TMCA vehicle, but it was the current model car we were testing against. The actual prototype was about 3 cars up in the on the freeway that just looked like a normal car. So I thought that was there's been a lot of focus on actually getting these cars out there. They were in the real world, but they were really hidden in plain sight because we had a standard LC300 body sitting on top of them.
Yeah. Now, question about crawl control, maybe one for Christy. So. My kind of theory on crawl control, interested you validate this or not, is that the brake traction control is more effective in crawl control than it is with human control, to use that term. And I think the reason why is because with crawl control, the car is providing the throttle input, so the car knows what it's going to do and it doesn't have to react. Whereas with human control, the human's providing the throttle input and then the car has to figure it out and then react. Because I've had Prados in situations where I can't drive it out. I put it in crawl control and it can drive out. Any comment on that?
Yeah, crawl control is fantastic for things like that, especially when even in sand, when you get stuck in the sand, you just turn crawl on and out you go. I can tell you that the crawl control of LandCruiser 300, I mean, you did experience this at the proto drive. The new brake actuator really allows that new crawl to be very smooth and very controlled. And, we had that really fine speed control if you compare that to the previous model. With respect to how it works with versus the human driver, I think you're right. The other thing is that the reaction time of the human driver could never be as good as what the actuator can perform, especially now with our new brake actuator. So it's really there that, as I mentioned earlier, so your inputs are earlier, they're smoother, and they're because they're earlier, they're not as big as what they might otherwise be.
Okay, so interesting point in the reaction time then, because I guess if the vehicle has its wheels slipping a little bit, and then the human driver's got to notice that, apply the throttle, and then that extra torque's going to come to the front axle and it's going to go there. Whereas with the computer, that feedback loop is much shortened, so it can actually do that a lot quicker.
Yeah, they could pick up on when that wheel starts slipping much earlier as well. So, as I said earlier, the brake application is much earlier than if you're just relying on the driver input to the driver to kind of detect that wheel slip.
Okay. Where would you recommend owners use crawl control or not use crawl control?
Oh, I think crawl control is underutilized. People should really to get familiar with it and find out where you can really use it. You could use it uphill, downhill. You can use it on the flat. You could even use it, rock crawling. Like I said, it's really good for escaping out of things like sand and mud. So I really encourage people. I mean, MTS traction control, absolutely fantastic. But also, get familiar with your crawl because it's a really excellent tool to have in your tool chest.
This conversation sort of brings out to me how incredible vehicles like this are. There are so many computers with so many different sensors making so many tiny adjustments. You don't know. I mean, you're driving along, you don't know that I don't know, your rear left shock absorber is being stiffened by a micro bit and the KDSS has come in there, or the VSC computer has just applied a fraction more brake pressure here and there. It's amazing. Do you ever drive the car with all of the electronics completely disabled? Do you ever do that?
Generally during development, that's where you start with. Electronics should always be any control system. If you've got a very good core fundamental design of your platform, the vehicle will work better, more naturally, and then you can use the electronics to really maximize that potential. If you've got a platform that doesn't have the right ingredients as a base, the electronics are always having to kind of compensate for something as opposed to add to it. So when we do start development, we make sure the core things such as wheel articulation, ground clearance, ramp over and departure angles, low RPM torque, all those, if you're talking, say, off-road, they need to be really good as a platform. And then the MTS system then becomes, I'm not going to say the icing on the cake, because it really helps. It's more than that, but it's not having to compensate for problems. It's helping to really expand the platform.
Yeah, look, I totally get that. I guess there's two ways going for it. Get the basics right first, so the vehicle works without the electronics, then add the electronics on. But then again, on the other side, you could argue that if you just developed it purely to rely on the electronics, it might be better than if it was developed non-electronics and electronics added. So it's hard, isn't it?
With the electronics, it allows us to make trade-off decisions we wouldn't have made previously.
Yeah.
So, for example, wheel articulation. If you want a bit more roll stiffness on a vehicle without MTS, you would really lose a lot of articulation traction. Whereas now the MTS system is so capable in developing tire traction that you can have a little bit less articulation, for example, and you could prioritize a bit more on-road performance. So yeah, the vehicle has to work as a system, but we do start by trying to make sure that the base platform is as capable and as balanced as possible, and then that makes the job of the electronics really adding to the car as opposed to trying to mask problems.
Now, in terms of ergonomics and long distance, the chief engineer related how he drove a 200 all the way around Australia and got a lot of feedback for that. How is that translated into making, and early owner feedback is saying, look, it does feel a more comfortable vehicle to drive. What makes it a more comfortable vehicle to drive? Is it driving position, the suspension? What goes into making it a better long distance cruiser? Excuse the pun. Yeah,
that's a good question. Look, it is about having the package, and it's about, again, right from the very beginning, that 2014 drive, that TMC sent a number of engineers out to Australia, and in conjunction with a lot of our local engineers, we actually did a big lap of the country. They then went to a number of other countries to do a similar thing. They called it their 5-continent drive. What they learned from that, those really long distance drives, is that you can, if a car, you can prioritize comfort on a vehicle, but if the steering doesn't have enough feel around center, and the body is moving too much, those things can become fatiguing over time. If you've got, and it's about getting the balance of the whole vehicle. If your steering is too responsive and the car's too firm, it's a tiring drive. But if the car feels too disconnected, it can become a bit of a fatiguing drive because you're kind of having to concentrate. So it was about trying to get that balance, and a lot of objective benchmarking and feedback goes into this to get the balance of a car that is direct enough that you're not having to worry about it wandering, but not too direct, because then you're constantly worrying that you're going to go out of the lane, especially if you're carrying weights or towing. So there was a lot of development of steering, suspension tune, tire feeling. All those all come together to make a very balanced car. It's not a sports car. It's not, it's an SUV that needs to be very linear, and Toyota used the words confident and natural to drive. It does what you want, how you want it to do it. Yeah.
Okay. Anything to do with seating position or cabin ergonomics, things like that?
And actually, you'll notice that the last couple of generations of Toyotas, there was a big focus on seats, improving material, improving seating position, so that it all comes together in what they call this confident and natural. It's how the whole, you're not just focused on the steering. It's you put an input in, and does it feel like do you feel connected to what the vehicle is doing? Can you feel that?
Yeah.
So that whole package comes together.
Is there likely to be a hybrid version of the 300 in line with Toyota's electrification strategy, or not?
I can't comment on specific future releases, but Toyota has said that by 2030 there will be an electrified version of every vehicle in the range. So it's coming. But as per, I think the chief engineer also talked on this during the press launch, is that whenever something is released as a LandCruiser, it has to be a LandCruiser.
Yeah.
So anything that was released on this with the LandCruiser name must be fit for purpose for how the customers use these vehicles: off-road, towing, remote areas, etc. So that's the core value of the LandCruiser, and that won't be compromised. That fit for purpose.
All right. What other sort of durability designs are there for the Outback? We've talked about the suspension, talked about the fuel. corrugation's absolutely killer vehicle. So how do you design to sort of do that 1,000-kilometre shopping run you talked about on corrugation day after day after day?
Well, look, and this was a really important factor. Yeah, the vehicle has a ladder frame, and ladder frames are actually they perform better on those kind of corrugation roads for a number of reasons. One, you can make the frame out of very high tensile, very strong material, so you've got a very strong base structure. Secondly, because you're isolating the body from the frame through the rubber bushing mounts, that not only gives better durability for the body, which means that the chassis can take the pounding of the corrugations, but the body's less input. It also means as a driver, you get less input. So on these really, for customers that are driving on corrugated roads day after day, a vehicle with a body on frame design is actually a more comfortable vehicle, as well as being a much more durable vehicle. These inputs, there's been a lot of measurements over the years on corrugations. Australia's corrugations are famous around the world for their durability on a car, and so that they are a key factor into the design of the car.
Where do you see the future of vehicle electronics going, vehicle off-road electronics going? More automation, more removing of the driver?
Oh, that's a really good question. So I'm very excited about the future of off-road. I think that it can only get better, it can only get more exciting, and we can only get kind of more capable with the equipment that we have coming up. I mean, there's still always going to be that driver skill requirement involved. I mean, having said that, we're kind of enabling with LandCruiser 300, we've got that auto mode, we've got, all these great MTS modes to kind of enable the maybe inexperienced driver to kind of access these off-road environments, maybe like they haven't been able to in the past. So, we're making the vehicle much more available to your average kind of, off-road enthusiast. So, there's still a little bit of skill required if you want to turn your MTS off, but if you have it on, you're not going to get in trouble. You're going to be really, you're going to really enjoy the experience.
Yeah. Okay, so if you had a vehicle which was electric individual wheel drive, just motor at each wheel, would that open up new possibilities for vehicle dynamics compared to a single motor and differentials and everything else?
I can speak to that from a personal point of view. I'm very excited about the idea of this technology and see what's kind of coming out of the industry. I think that would be really exciting. I'd love to see that.
Yeah.
Just from a personal point of view.
Yeah, sure. Same here as well. I think it's going to reduce driver skill, which is sad, but I think it's going to open up absolutely a lot of new capability there as well. So I hope you found that video useful. Please like, subscribe, share, etc. And also consider supporting me on Patreon. If you do have any questions, please just drop them in the comments, and thanks for watching.